All right, Algebra 2, Lesson 2-4, Complex Numbers and Operations. So the first thing is that we're going to have this thing called an imaginary unit or number. And what it is, let me start over on this page. So sometimes you get square roots of negatives, and we usually say that you can't do that, or many times. But there are places in real life where they do. Nanotechnologies, you know, cell phones, things that are very small technologies, use this concept, and it happens a lot in electricity because, like, you have ones and zeros, the circuits are on and off. So you have this thing where they say, well, wait a minute, okay, we're going to say we have I that's a square root of -1, and then you can end up working with it, where otherwise they said you couldn't. And at some point then, when this was figured out, we're actually able to do some really powerful mathematics with it. So if I is a square root of -1, would I squared be the square root of -1 times the square root of -1? And what's anything times itself? When it's square rooted, isn't it just itself? That's kind of an example, a simple example right there, where this square root of -1, we would have said it couldn't work or it wouldn't exist, but look, we turned it into something real from something that was imaginary. So then we'll go on to this I to the third. Is that I to the second times I to the first, but I to the second, this I to the second, we just proved up here was -1. Times this I then. So I to the third is nothing more than a -I. And then we're just going to go one more level, and I'll show you why that is. So I to the fourth, would you hopefully agree that that's I squared times I squared? But here we just set up here that I squared is just -1. So you could put -1 times -1 and turn it into a real number, +1. Now some people will say, well, they would rather do something like this, and that's okay, because what's -1 squared? It's also 1. So taking this imaginary idea and turning it into some things that actually are real can make this a concept that's pretty powerful. So this whole thing comes about back here. Problems might look something like this. Hopefully you understand that x squared equals 25. I want to solve for x, square root both sides. If I ask somebody what the square root of 25 is, usually they say 5, but if you go back to the original problem here, isn't -5 times -5 also? So whenever you do that to both sides, you need positive or negative. Well, what happened on this one? So here we have this square root of x squared is x. There's my positive or negative. My square root of this -25, well, think about it this way. It's -25 times -1. So therefore, square root of 25, square root of -1, multiplied. Square root of 25 is 5. What did I say on this other page that the square root of -1 was going to be called? Square root of -1 is I, this imaginary number, and bring this positive or negative down in front. It's kind of weird, but makes it some really powerful stuff that we otherwise wouldn't have been able to do. So any complex number is a number that has a real part and an imaginary part. So this would be an example of a complex number. This would be anything. Now, the one that I always think is interesting is, what if I just have the imaginary number part? Well, it's definitely an imaginary number, but if I add a real part onto there, like the real number 0, could that be a form of a complex number as well? And some people might argue it, but I would contend the answer is yes there. Then you're going to be asked to add and subtract or find the sum and the difference of these complex numbers. It's just combining like terms. Don't make it hard. So in this case, 2 plus 5. And the 7i, add on 3i. gives me 10i's. That's all. And if you wrote 10i plus 7, that's okay. Addition is commutative. You can change the order. Yeah. So then how about this other example with the difference or subtraction? So be careful. This negative here needs to go on both of these over here. Just be careful. If I take the 5i minus the 6i, so that's a negative I. 5i's take away 6, I'm going to be short 1. And negative 2 minus negative 5, that's going to turn into a plus 5, right? So negative 2 plus 5 plus 3, or 3 minus I, or 3 plus a negative I. However, usually you'll see them written with the real number first and then the imaginary, but it doesn't make it wrong if you do it the other way. And continuing, well, what if we are asked to multiply or find a product? So in that case, 3i times 2i, 6i squared. 3i times this negative 5, negative 15i. Do you remember what I said I squared was when you were back over here on this page? What's I squared? Well, I squared was negative 1. So in this problem that we're just doing, this I squared right here is a negative 1. So I've got 6 times negative 1 minus my 15i. So this is negative 6 minus 15i for your final answer. How about this one? 3i plus 2 and 2i minus 5, their product. So distribute everything out. 6i squared there. Negative 15i there. 4i there. And a negative 10. Combine your like terms. What do we have? We've got 6i squared. We've got a negative 11i and a minus 10, but are we done? I don't think so. What about this? I squared. So 6 times the negative 1. Remember, I squared was square root of negative 1 times square root of negative 1, which equaled negative 1, just in case you forgot how we got that. Minus your 11i minus 10. So that's negative 6. Combined with that negative 10 makes a negative 16 minus 11i. Let's see, 40i. I don't think I made a mistake there, but let's see on the next one. So the next thing is something called conjugates. And the conjugate is really nice because it actually takes and will get rid of, see how this is a complex number, an imaginary and a real part? This is as well. Watch what happens when we multiply them together. The 2i times 2i, 4i squared. Well, in conjugates, because this one's a plus and this one's a minus on the same exact thing, your positive 10i and a negative 10i there, they just wipe each other out. And then we have my positive 5 times my negative 5, negative 25. So these are gone, leaving me at the 4i squared minus 25. But what was I squared again? Negative 1. So 4 times negative 1 here. That's negative 4 minus 25. We've got a negative 29. We took something that had imaginary stuff in it, turned it into something that was real. And that is the power of these imaginary numbers. Same thing over here, just one more time for practice. 36, negative 12i, positive 12i, see it cancels out. And then your negative 4i squared. When you FOIL everything out there, those two are gone. 36 minus 4i squared, but the I squared was a negative 1. So that's going to be 36 plus 4, making a 40. Complex numbers turned into real numbers that we actually can work with. Now this one, they want us to basically take this. It's sort of like sometimes in, if you remember working with square roots, they don't like square roots left in the denominator. And so you did something like this to get rid of those. Hopefully you remember this. If you multiply by square root of 5 over square root of 5, that's just another name for 1. So that'd be 3 square roots of 5 over 5. And why do they? Well, if I asked you 3 divided by a square root of 5, and I asked you how much do you have, I'd have 3 whole things, and I split them up into a square root of 5 groups. Well, how many are in each group? It's like, I don't know. But over here, if I have 3 square roots of 5 and I split them into 5 groups, do I not have 3/5 of the square root of 5 in each group? So it's a conceptual thing so that it turns it into a way that it can be worked with. So watch what happens up here. If you take this 10 plus I, multiply by its conjugate, remember, that's going to turn it into a real number. So if I multiply by 10 minus I over itself, that's just another name for 1, right? That's not like I'm changing the value. It might look different, but that whole thing right there is just another way of writing a 1. Multiply by 1, value is the same. So I've got 5 times the 10 minus I in the numerator, and what happens in the denominator? See these conjugates? Should turn it into a real number. 10 times 10, 100, minus a 10i, plus a 10i, and minus an I squared. When you FOIL all those parts out, there's your minus 10i, there's your plus 10i, and there's your minus I squared. So we've got 50 minus 5i all over. Middle 2 with the i's cancel each other out in conjugates. So I've got 100 minus, do you remember I squared was negative 1? So that's 101 on the denominator. And the last thing they'll usually do, so normally we get a common denominator to put these together. Well, in this case, it's like you're going to take it apart. Just go the opposite direction. So the 50 over 101 minus the 5 over 101 times the I like that. So there is my A, there is my B, when they were asking to write it in the form A plus BI. A would be the 50 over 101, B would be the negative 5 over 101. That's called rationalizing the denominator or writing it in that complex number A plus BI form. And then what if I have a problem where I need to factor a sum? So over here on the right, you can see what I did here. If I had x squared plus 25 and I asked you to factor it, is plus 25 the same as minus a negative right there? Minus a negative. So when I have that, that would be the same. So now I'm subtracting is negative 25 like this. So then I could write an x minus 5i and an x plus 5i for my factors, because the negative 25 right here, I times I would be an I squared, negative 5 times positive 5. And we could write that then in this factored form. Well, how would that look over here? Again, you've got your x minus negative 49. That would be x plus 49, right? And so if I said to you, this negative 49 is like a negative 7 squared, so that'd be x minus a 7i and x plus a 7i, because the square root of negative 49 is 7i. Square root of negative 49, if you think of it as 49 times negative 1, square root of 49 times square root of negative 1, there's my 7, and this is I. So it can be written that way as a perfect square. So if we're going to solve this one, solve it by factoring. So if you're going to have to factor this, again, this would be your x. You could rewrite this if you wanted to this way. Hopefully you're agreeing by now that negative 10 This is minus and a minus, that makes the plus. This minus times this minus makes that plus. There's my 100. And that now from, how do I write this? I have an x minus my 10i and an x plus my 10i. Zero product property says set each of them equal to 0. And subtract the other side, add the other side. And I've got a 10i here. And on this one, I would have a negative 10i. So where I said I couldn't solve it before, now I can. You could do this by factoring as well. If you subtracted your 100 to the other side, square root both sides, don't forget your plus or minus like we've talked about before. And the square root of the 100 would be the 10, and the square root of the negative would be like a negative 1, and I, so you could also think of it that way. And that's everything that is in lesson 2-4.